Today I'd like to talk to you about design, about architecture, about aspirations and the emotional aspects of design. I'm not going to stand here and try and justify whether steel is better or not. I think there's several other experts that are going to do that. I'm fundamentally here to show you how, through case studies, I'm going to show you a few projects, and I have over 200 slides, so I got to go really fast. But I'll try to show you how steel has been used, and again, it's never about steel. It's about the design, right? It's about the aspirations. It's about all the reasons we build buildings. We have goals about creating space. We have goals about creating place. We have aspirations about reaching the sky, and that's why we build buildings. And I think the way to look at steel is to use it when it's logical. And through our projects, I hope we can demonstrate that steel comes to the rescue most of the times, purely because it's the obvious choice. I'm going to start with, so I have a lot of slides, so it's all about, the images. So please, I hope everybody has a view of either this screen or the other one. It would have been really nice to have a bigger screen, but so I'll start with a very small project, extremely small. I think the smallest project I've done in my life. This is 700 square feet in Bangalore. It's our office. We leased the roof of a retail building, a commercial building on a main street in Bangalore, and we decided to put up our own office on top. What did we do? We built a frame out of steel, and we pretty much prefabricated most of the members. I'll walk you quickly through the construction. So most of it is prefabricated. There's not a single weld in the project. It's all bolted. The stairs, it's a folded plate. So that's the final structure. We actually designed furniture out of steel. As you can see, here's a bent plate, 5 millimeters. That's how it looks finished. Our tables are made out of steel, desks rather. The benches that we have outside in our terrace, outdoor seating, is made out of steel. So here's some finished images. So I think what I'm trying to highlight is, for a 600 or 700 square foot space, I think fundamentally that's on top of an 80s building, a roof of an 80s building. The owner of the building clearly told us we couldn't mess with the structure. We pretty much were left with the idea of trying to create a box, a prefabricated box, and dropping it onto the roof, and that was the most logical solution. So steel is versatile. And here's another project. This was my last project in the States. So I lived and worked in the States for 21 years as a design director at Gensler. Before that, Skidmore, Owings and Merrill. So this was a project I did in the US. This is for HP. It's their world headquarters in Palo Alto. It's the Executive Briefing Center. This is where HP would make a deal with another business partner. It's a building that's very high profile. It's $700 a square foot, so that's a pretty high budget. But the idea was to make it very versatile and make it a space that's really user-friendly and can adapt quickly. This is the floor plan. Here's the finished building. Tall atrium. What you see, is there a pointer? It's okay. So what you see up above, the white soffit, is actually a 7-foot deep truss, steel of course. And because we have cable net, the glass is cable net. It's basically cable structure that holds the glass. And the cable is in high tension. We had to have something really rigid, and so we had a steel truss, some interior spaces, and all of this is steel. And one of the things I'd like to highlight here is the fact that a steel building doesn't have to look like it's steel. There's seldom a point in this building, maybe in a couple of instances, where you realize that it's a steel building. So, you have a lot of spaces that are very quickly adaptable. This is a cafe, but also functions as a meeting hall. And what steel does is with the long spans, you can create openings, you can create, partitions that are folding, and so on. I mean, things like creating the entry portal, again, it's a steel framed structure, very simple tubular structure, 3 inches by 3 inches. And then, of course, it's clad with steel plate, stainless steel plate in this case. This is the nerve center. And so that's that. So I'm going to try and show you from the compact to the very, very large and tall buildings that I've worked on and designed. In the tall building section, the main reason, one of the main reasons, like the gentleman before me from Phoenix says, quote, speed is a major issue. Speed becomes a really important aspect. Here's a project I did last year in Bangalore. It's a 1 million square foot office building for a multinational company called NetApp. They're a cloud computing company out of the Silicon Valley. Interesting story. And I really am interested in the emotional aspects of buildings and why, what emotions cause these great buildings. This building was designed in concrete. The shop drawings were done, the footings were done, actually dug, and I think done. And then that's when we came into the picture. And the client, being an American company, the director of the company was actually somebody that worked in the States for 35 years or so. They wanted to change it into steel at the last minute. The shop, like I said, everything was approved. The design was done for concrete. The curtain wall was done, everything. And at the very last minute, we changed it to steel and we redesigned the building and got it done in record time. 1 million square feet, 1,000 crore project. It seats about 3,000 people. And this is the complete, it's actually been completed in April last year. So it's been around for almost a year now. So again, I mean, the reason steel was chosen was speed, for versatility, for the fact that they wanted to have a building that was forward-looking, progressive, and wanted to reflect their value system through the building, a company that's progressive, a company that's doing all the things right. Steel is beautiful, not steel itself, but steel allows you to create really beautiful buildings because it's flexible, it gives you the ability to create a lot more adaptable spaces. Here's a building I did in San Francisco. This is actually outside San Francisco. It's along Highway 101, which is from the airport, San Francisco International Airport, to San Francisco, the city. And we designed this right before the recession. Again, interesting story here. It's a private developer. The hill behind is actually a conservation area, so you can't build anywhere close to the hill. But for some great reason, the developer managed to get this one piece of land. So there was no immediate context. There's nothing around, right? There's no other buildings except the highway. And so I was the design director at SOM. And SOM, we do mostly minimalist, boxy buildings, simple buildings. And the client wanted that. But for the longest time, it just didn't feel right because there was no context. There was only the hill and then there's the highway. And so after almost a year of various design schemes, we finally settled on a curvaceous, curvilinear building. And because it responded to the dynamism of the highway. The only way you see the building is when you're driving at 70 miles an hour on the highway. So it kind of made sense. The second building is actually now being built. The first one was built in 2008-9. And since the recession hit, they didn't build a second build, but now it's complete. So again, a lot of details here. Steel allowed us to do some amazing things. The parapet is actually 8 meters tall. And the concept was a folding fabric, so it allowed you to, this is actually a drawing showing you the structure for the parapet. That's the floor plan, facade details, interior shots, and again a lot of detail showing how how we frame the parapet, the curtain wall parapet. So I'm going to next show you some taller buildings, buildings that I designed mostly in China. So sustainability becomes a real, this one's in the US. Sustainability is, I think a big factor, primarily because steel is recyclable, and I think, if you were to consider buildings, most of our buildings lifespan around 30 to 50 years, what happens when you have to demolish it? There's also talk about, a lot more recycling of buildings. I don't think we're going to see in the future buildings that are 100, 200 years old. I think the old will give way to the new. So what happens to the building material? So sustainability is a huge thing, and steel is very sustainable in that sense. So this is a project that is the greenest tower in North America. This was for a bank called PNC. They are the second largest bank in America. And they wanted to make, the CEO, we worked directly with the CEO, his vision was to create the greenest building in America. So we pretty much put it's in Pittsburgh, downtown. They actually own a bunch of property in downtown Pittsburgh. The building on the left is also their building that we completed a few years back, and the building on the right is the building I'm talking about. And he was driven by the fact that he wanted to create the most sustainable building in the world. For 6 months, we got on his private jet and went and saw all sustainable buildings all over the world. Europe, he would just call us and say, let's go to Europe. We would go to Paris, we would go to London and see green buildings, towers mostly, tall buildings. And so we learned all the sustainability techniques, and we pretty much, here are all the strategies we adapted. We pretty much put everything into the building. Everything from double skin facade, to geothermal, to photovoltaics, to solar chimney, to of course the passive ones like orientation and so on. So we pretty much didn't leave anything. We threw the kitchen sink. We put everything, every sustainable concept into the project and created this building. Of course, the fundamental building material, after all the research we did, the fundamental building material, the structural element had to be steel, of course for obvious reasons. I won't get too much into the detail of the sustainability aspects. Here's a double skin facade which essentially creates a column of insulated air that allows the buildings to breathe. So you actually have fresh air in the building. Different concepts I did for the facade. And the building actually breathes through these parallel projected windows. This is the completed project in downtown Pittsburgh. And here are the windows that actually, they're on a BMS system, and depending on the ambient temperature outside, it either opens or closes or opens to varying degrees to allow for the building to breathe. More shots. And the other very important strategy was to create a series of tall atria, which essentially allowed you to play stack effect of air, which then allows you to modulate the interior temperature. This is a shot of the atrium, one of the atria, tall 3, 4-story, 7-story spaces. And that's the building bang in the middle of downtown Pittsburgh. Steel is modular. When you want to build fast and you want to build efficiently, modularity becomes a huge aspect. The fact that you can repeat the process, once you've perfected it, you repeat it multiple times in a shop, not on a field, but in a shop. I think that becomes really important. And that played the key role in this project. This tower is called Jinmin Jinta. I was the lead designer for this. We completed this in 2006. It's in a city called Tianjin, which is 100 miles east of Beijing. And this was the mayor's vision. The mayor of the city was personally involved in this building. He wanted to establish his city as a viable competition to Beijing. Businesses that didn't want to be in Beijing due to pollution, due to traffic congestion and so on, he wanted them to come to Tianjin. So what did he do? He commissioned a tall building, and he wanted it to be beautiful. The river in front of this building is called River Haiwo, and Chinese love metaphors. They're all about poetry and metaphors. And this building was supposed to be the pearl on the river of Haiwo, and so we came up with a structure. It's part of a larger campus. We came up with a structure with a serrated sort of elliptical structure plan, very gently curving to the top. And of course, various elements of the building. And again, steel was the material of choice for various reasons. The way the building curves, we actually looked at concrete, believe it or not, or a composite structure, and we just weren't able to create that tapering effect, which the mayor liked so much. Various details there, some interior shots, and the construction process. Huge tubular steel columns along the periphery, along the outer edge of the building. So I used to make regular trips to China, and the amazing thing is steel no matter where you work. You work in India, you work in the US, you work in the Middle East or China. The detailing, and the structural engineer was from the US, and the Chinese factories were making the steel, and the drawings were all very clear, and that's the beauty, I think. Here's the finished product. So finally, I'm going to show you the tallest part of the buildings I've designed. This one's, when it's complete, will be the second tallest building in the world. This I designed in 2015. I spent a year and a half in China, in Shanghai, designing this building. And this is called the Zugor Tower. It's 749 meters tall. It's second to Burj Khalifa. Of course, depending on when this gets built, there may be other buildings that actually beat it. If Kingdom Tower gets built, it's a kilometer tall. This is 3/4 of a kilometer, 750 meters. So just a quarter kilometer less than quarter mile, kilometer less than a kilometer. This is in a town called Suzhou. Suzhou is 60 kilometers west of Shanghai. It's an industrial town. Again, it's trying to beat Shanghai, and they wanted to. And a very interesting story. The owner of the building, we interacted with the owner. It's a rags to riches story. He was a construction worker about 20 years back. He literally was living in a slum, and through his innovation, through his perseverance and so on, he became the third richest guy in China. And he wanted to own the tallest building in China. So sometimes, we build because of ego, which is not a bad thing. So his explicit direction to us was, I want a building that's very tall, the tallest in China, but I don't want to spend a lot of money. So the building is pretty vanilla. If you look at the facade, it's a very straightforward facade, and of course we looked at various materials, for the podium, for the base, and so on. But the basic building material was steel again. So steel is very flexible. We created a lot of variety of spaces. There's the tower, the one highlighted, the third building. The first one is Kingdom Tower, second one is Burj Khalifa, and the third one is the project I'm talking about, Zugor Tower. These are floor plans from different parts of the building. I'll just walk you through the design process of the podium. The podium is a building, the little tiny building on the right. That building actually is a high-rise building by itself. It's about 80 meters tall. So again, Chinese love metaphors, they love poetry. They will not accept a building as a building. They want it to be connected to poetry, to life, and so on. So we created a concept called the lantern. So we said the podium is a lantern that sort of shines the light on the tower. They love this kind of stuff. We used a product called channel glass, which is a very luminescent product. Different options for the podium. Again, we used the material inside in the lobby. There was a 16-meter tall entry pavilion. The podium was a high-end retail space, very high-end. Brands like Gucci and Armani and so on were asked to come and have a shop here purely by invitation. We, again, in steel, in Shanghai, there's a great tradition of what we call jali here, which is, lattice, windows and openings with jali. We actually went ahead and created a custom lattice. It actually reads Suzhou if you read it. Again, these are all made out of MS steel. Different options we studied. This is a stainless steel facade, which has got LED impregnated into it, so you can have branding that changes constantly. At night, the whole building can light and get lit up because it's got LED inside. Here's the material we were using. The owner wanted to use stone, so we looked at an option for stone. Of course, it didn't work out. Stone facade, aluminum panels, ceramic frit. So then, after we completed the building, the crown, the very top of the building, became a big issue because he didn't like the design of the crown. So here are sketches I did. These are like hundreds of options of how the building can terminate. What crown do you put on this very tall building? Different ideas. I won't get too far into it. We tried to argue with the owner that buildings don't need crowns. Here are buildings with crowns. Here are buildings without crowns. But he didn't buy it. He said, no, my building should have a crown. So finally we came up with the TMD that you use to dampen deflection in a tall building came to our rescue. We termed this as the mother of pearl, right? Again, symbolism and metaphors in China. We said the TMD is going to be the mother of the pearl, and that's going to be sort of the main feature of the crown. And so we created, again, we went on to the seashell, the iridescence, and we found a glass that actually does this, which is, it sort of refracts light in a rainbow pattern. And then, of course, what you see there in the top, if I can point, yeah, right there, that's the TMD, and we created a housing, of course, for it. Different ideas on how to integrate it, and of course, none of them were really working for him. And finally, we came up with a concept very much from the seashell, and looked at the inside of the seashell, and you get these beautiful layers inside the seashell. And we used that as a concept, these layers here. And turns out he liked it. After almost 6 months of different options, he finally liked this. And, we created a glazing that's, again, another metaphor, the bridal veil. Here are some other options. Again, how do you use steel to create this? So we got the concept done, but then how do you frame it? And, this is an option for the glazing around the TMD, as you can see here. There's an observation deck up there, so it was really important. There's actually people that will be coming there. And so these are different concepts and different materials we considered to create that crown. And here are some structural drawings of how we framed this thing. I mean, you have to imagine, you have to understand that it's a massive thing up in the sky. So this is what the crown looks like. We are 3/4 of a kilometer up in the sky. So here are some structural drawings. Here are some building materials, it's a metal mesh. Here's another material that's actually a laminated glass with a metal mesh that's sandwiched. So that was the crown. And then, things like the entry canopy become big issues. So we tried various options, and this is what goes into the design process. I think I don't know how many of your architects, you'll relate with me. A lot of times clients don't see why we are so passionate or why we charge what we charge, or there's hundreds of options we do before we actually select the option. But anyway, here's different versions, all again out of steel. Here's the construction site as it stands today. The podium is done. Finally, I just added this last minute. We just started a project in Hyderabad next to T-Hub Phase 2. We just got awarded the project. We're really excited about this project. Again, it's going to be steel. It's what is called T-Works. The government has come up with an amazing initiative, and it's the brainchild of the minister, KTR, creating a space called T-Works, which is essentially a maker's lab. Anybody with an idea to invent something, there's a housewife that is cooking and suddenly comes up an idea to make a new type of utensil or a pressure cooker. Where does she go, right? There's an auto driver who wants to innovate on the auto. He wants to create a new type of engine. Where does he go? A school student wants to create a robot. Where do they go? The T-Works is a building where essentially anybody, not just from Telangana, anybody from India can walk in for free, almost, I think, and build whatever they want. It's a prototyping space. There's 3D printers, there's laser cutters, there's CNC routers, there's wood shops, there's finish shops, metal shops. And so it's a really beautiful building, I think. I'd like to highlight this building. This is 80 meters building that's just basically cantilevered. So we don't have a lot of renderings. We just started this a week back, so I can't show you too much. But essentially, it's 3 buildings. Here's T-Hub Phase 2. Here's what's called Image Tower, which is a 100-meter building. And here is T-Works. This building is actually resting on 2 ends, and that span is about 80 meters.